Hello everyone, in today's video we're going to talk about solving radical equations. So you can see we have 3 examples here today, and all of them have radicals in them. So let's start with this example here. We're going to say solve for x, radical x plus 8 plus 15 equals 18. So remember, when we're solving an equation, our goal is to get the x all by itself, right? So let's do everything we can to get that x alone. The first thing we're going to do is get rid of this plus 15 by doing minus 15 to both sides. And we get radical x plus 8 equals 3. Now, I'd love to be able to get rid of that 8 by doing a minus 8. But I can't do that because it's inside the radical. It's like a protective shell, and I need to break through before I can get inside. So to get rid of a radical, we undo square rooting something by squaring something. So I'm going to square both sides. When I square something that's being square rooted, the square root sign just drops and we're left with x plus 8. Over here we have 3 squared is 9. And now that that shell is gone, now I can solve for x by doing minus 8 to both sides. And we get x equals 1. To check this, I would just take this 1 and put it up here. 1 plus 8 is 9. The square root of 9 is 3. 3 plus 15 is 18. Example 2 looks very similar, but you'll notice that this has an x plus 1. When we squared this number over here, we know how to square numbers fairly easily. But when I go for my first step here to square both sides, you'll have to remind yourself squaring a binomial is not just squaring the x and squaring the 1. Squaring a binomial is writing it twice and then either doing FOIL like this or doing box method like this. X squared, x squared plus 2x plus 1. So if x plus 1 squared, a lot of people just say it's x squared plus 1 squared. That's not how it works. You have to do FOIL or you have to do box method. All right, so let's do that. Let's square both sides. And we get 15 minus 3x. The square cancels the square root sign. And that simplifies to x squared plus 2x plus 1. Little line there to show that that's separate. All right, and now let's solve this equation. There's a squared, so we're going to get the squared. We're going to make it equal to 0 because when there's a squared, we want to either do factoring or quadratic formula. And for both of those, we want it equal to 0. So let's move the 15 and the 3x over here. Minus 15 plus 3x. We end up with 0 equals x squared plus 5x minus 14. I'm going to pause for a second. And I'm back. So next step, we're going to solve this. Let's solve it using the quadratic formula. So a is 1, b is 5, c is negative 14. Remember, there's a 1 in front of that. The quadratic formula is negative b plus or minus b squared minus 4ac. And square root all over 2a. And when we do that, we get the values of x that make this true. So let's solve this. Let's put in our negative 5 plus or minus 5 squared minus 4 times 1 times negative 14 all over 2a, which is all over 2. So we're just going to type all that on our calculator. And we get negative 5 plus or minus square root of 25 minus 4 times 2. This whole numerator works out to 4 when I use the plus divided by 2. So one of our answers is 2. And the other answer, when I use that as, remember, plus or minus, you got to do it twice. Once with a plus, once with a minus. When I do it as a minus, I get negative 7 as the other answer. Now, here's the interesting thing. When you're doing radical problems, you have to check to make sure if these answers are even allowed. We didn't do this on the first question. I checked it, but I didn't talk about this. One of these answers is actually going to be an answer you can't have. That's the negative 7. Not because it's negative, but because when you put it in, the radical ends up being negative, right? If we put negative 7 in there, Oh, I lied. The negative 7 times the negative 3 is going to be a positive 21. 21 plus 15 is 36. The square root of 36 is 6. And then over here, negative 7 plus 1 is negative 6. There you go. That's why it doesn't work. So when I put the negative 7 in there, I get radical 36 equals, and when I put the negative 7 in there, I get negative 6. And the square root of 36 is not negative 6. That's not true. We have to reject the negative 7. So sometimes you reject it, like I was saying. You reject it because when you put it in, it makes a negative radical. That's not why we rejected this one. We rejected it because when we put it into both sides, we got a false statement. Let's see if the 2 works. 2 times 3 is 6. 15 minus 6 is 9. Square root of 9 is equal to 2 plus 1 is 3. Square root of 9 is indeed 3. That one checks out. So that one really is an answer. Let's do one more example here. We have radical x minus 2 equals radical x minus 8. The one on the right is completely in the square root sign, but the one on the left, only the x is in the square root sign. So it doesn't matter if the 2 is there or there. Either way, it's not going to go away. It's not going to combine with anything. So we'll just leave it where it is. Let's just start by squaring both sides. So I'm going to square this. And I'm going to square this. This one, square rooting a square rooting, squaring a square root, works out to just be what's inside. So x minus 8. But this one, just like over here, we got to be a little more careful here. We have radical x minus 2 times radical x minus 2. I'm going to use FOIL this time to multiply it. Radical x times radical x is just x. Radical x times negative 2 is negative 2 radical x. When you multiply it, one's in the radical and the other one's not. You just leave them separate. And then negative 2 times radical x is negative 2 radical x. And negative 2 times negative 2 is plus 4. So now, interesting, we tried to get rid of radicals and we sort of succeeded. You still have radicals, so we might have to deal with that in a second. Well, let's organize all this because we can combine some like terms here. Let's move this x over here. It's a positive x, and then move it over there, it becomes a negative x. So those just, those cancel out. We have negative 2 radical x minus 2 radical x. Let's move the 4 over there too, and we get negative 12. All right, we can combine those. You can combine radicals as long as the number under the radical is the same. You leave the radical alone, and you just combine the numbers out front. So this would be negative 4 radical x equals negative 12. And since that negative 4 is not inside of the radical, I can get rid of it by doing divided by negative 4. And we get radical x is equal to 3. Hey, now we're in a place where we have a radical we got to get rid of. We're going to square again. We square both sides. And we get x equals 9. We only got one answer here, but we still need to check to see if it's allowed or if it's extraneous. So let's check. Radical 9, if I put it right there, I get 3 minus 2. This side equals 1. And over here, 9 minus 8 is 1. The square root of 1 is 1. So that one checks out. We're going to leave that answered. So that's all for today. Thank you for watching.